Welcome to the official YouTube channel of Random MCQ, an online provider of thousands of multiple-choice questions in engineering and other general subjects. Random MCQ also provided a number of online resources and references in variety of subjects. Check out Random MCQ at www.randommcq.com. Hello, I am John, and today, I am going to discuss series and parallel circuits. What is a series circuit? This figure is an example of series circuit. A series circuit is a circuit connection, in which two or more circuit elements are reconnected point to allow a single current path. The current, I, would be the same in all parts of the circuit. The supply voltage, E, is equal to the sum of the individual voltages, V1 and V2. What is a parallel circuit? This figure is an example of parallel circuit. A parallel circuit is a circuit connection, in which two or more circuit elements are connected across each other. The total current, I, would be the sum of the currents in each element, I1 and I2. The supply voltage, E, is equal to the individual voltages, V1 and V2. Now, let's go to resistors in series and parallel. Consider the given circuit, with two resistors, R1 and R2 in series, with a supply voltage, E. In a series circuit, the current through R1, which is I1, and R2, which is I2, are equal. Assuming that the total current in the circuit is I. Also, assume that voltage across R1 is V1, and across R2, is V2. We know that V1 plus V2 is equal to E, knowing that V is equal to I times R, V1 is equal to I1 times R1, and V2 is I2 times R2. From E equal to V1 and V2, we have IR is equal to I1 R1 plus I2 R2. Since I is equal to I1 and I2, the total resistance R is equal to R1 plus R2. Therefore, a series circuit, consisting of resistors R1 and R2, can be represented by a circuit consisting of a single resistance, R, where R is equal to R1 plus R2. Let's have an example. In the given circuit, R1 is equal to 8 ohms, and R2 is equal to 4. Assume that the supply E is equal to 12 volts. Since they are in series, the equivalent resistor R is equal to R1 plus R2. R then is equal to 8 ohms plus 4 ohms, which is equal to 12. R then is equal to 12 ohms. The total current I is equal to 12 volts divided by 12 ohms, which gives us 1 ampere. This is the same current through R1 and R2. The voltage through R1, which is V1, is equal to 1 ampere times 8 ohms, which totals to 8 volts. The voltage through R2, which is V2, is equal to 1 ampere times 4 ohms, which totals to 4 volts. Note that the total voltage is equal to 12 volts. Let's have another example. Consider the given circuit. Assume R1 is 4 ohms, R2 is 8 ohms and R3 is 6 ohms. The supply voltage is 6 volts. Find the voltage across R2. To find the voltage across R2, we need to find the total current, I. But first, we need to find the total equivalent resistance R, which is equal to R1 plus R2 plus R3. Therefore, R equals 4 plus 8 plus 6, and R equals 18 ohms. Solving for the current I, which is equals 6 volts divided by 18 ohms, current I equals 0.333 amperes. Since current is the same through all resistors, the current through R2 is also 0.333 amperes. Voltage across R2, V2, can be calculated as V2 equals I2 times R2, and V2 equals 0.333 times 8 ohms, which is equal to 2.667 volts. Let's talk now about parallel circuits. In this circuit, resistor R1 is in parallel with resistor R2, which are connected to a supply voltage, E. The total current I is equal to current through R1, I1, plus the current through R2, I2. The voltage V1 is equal to voltage V2. For this circuit, total current, I is equal to I1 plus I2. From Ohm's law, we can then write, I is equal to V divided by R. Then, we can write, V divided by R, is equal to V1, divided by R1, plus V2 divided by R2. Where R, is the total equivalent resistance. Since V equals V1 equals V2, then, 1 over R is equal to 1 over R1 plus 1 over R2. Thus, two parallel resistors, R1 and R2, can be replaced by a single equivalent resistor R, which can be calculated as 1 over R1 plus 1 over R2. This can also be written as R is equal to R1 times R2 divided by R1 plus R2. Let's have an example. In the given circuit, R1 is 8 ohms and R2 is 10 ohms. The supply voltage is 8 volts. Find the total current in the circuit. To find the total current, we need to calculate first the equivalent resistance, R. Thus, 1 over R is equal to 1 over R1 plus 1 over R2. 1 over R is equal to 1 over 8 plus 1 over 10, which gives us 0.125 plus 0.1. 1 over R is equal to 0.225. R then, is 1 over 0.225, or 4.44 ohms. In the equivalent circuit, since R is equal to 4.44 ohms, we can calculate the current I. The current I, is equal to 8 volts divided by 4.44 ohms. Current I is equal to 1.80 amperes.